Hope you guys are having a good day so far. You know, given that it's storming super hard, but I'm down with it. It's a little spooky, but it's alright. I'll deal. Alright. So I hope you guys had a good weekend. I'm sure some really exciting stuff went down. Oh no. Move that back over. Cool. Okay, so let's move on today with our matrix stuff. So we left off talking about matrix multiplication. All right, so let's start there. So a couple things. So before I even attempt to do this, I first just want to check to make sure that this is even possible. So this is a 2 by 3 matrix because there are 2 rows and 3 columns. This is a 3 by 2 matrix because there are 3 rows and 2 columns. So remember, it's important that these two numbers, these inner two numbers, have to be the same in order for us to be allowed to do matrix multiplication. If they are different numbers, then I would just stop right here and I would say this is impossible. And by the outer numbers, so since they're both 2, I know that this will equal some 2 by 2 matrix. All right, if I don't get a 2 by 2 matrix, something went wrong. Okay, so remember, we always do the rows of the first column with the with the rows of the first matrix with the column of the second matrix. So we multiply these things together. So we kind of match up. 2 times -2 is -4. -3 times 0 is 0. 1 times 5 is 5. All right, that's the first entry. And then I move over to the next column. 2 times -4 is -8. -3 times -1 is 3. 1 times 1 is 1. Move down to the next row. Start back over at the first column. 1 times -2, -2. 4 times 0 is 0. -7 plus 35. So not plus, but minus 35. And then move over to the next column. 1 times -4, -4. 4 times -1, -4. -7 times 1, -7. All right, and then we just do the simplifying. -4 plus 0 plus 5 is 1. -8 plus 3 plus 1 is -4. -2 minus 35 is -37. -4 minus 4 minus 7, -15. And just like we expected, also this is a 2 by 2 matrix. Oh no. All right. Questions? Okay, we're going to go on to talking about row operations today. Won't take super long. There's different operations we can do. So we talked about matrix operations like matrix addition, matrix subtraction, scalar multiplication, and matrix multiplication. But now these are operations that we will do specifically on the rows of a matrix. So we'll just change little bits of the matrix, not the entire matrix. So the first one is we can interchange rows. All that means is we switch places of any two rows. We do not change any of the values. All right, and the notation we'll use is just something like this. Okay, so this means, hey, we're switching. So row 1 and row 2 switch. Okay, that's all it means. I feel like this notation pretty clearly states that. Okay, so for example, let's see that. Let's do row 1 switch with row 3. Okay, so 5-1. Row 2 stays exactly the same. Nothing happens to row 2 in this case because this just says row 1 and row 3. And then -2, -4 down here. All right, so this row got moved down to row 3. And then the third row got moved down, or sorry, got moved up to row 1. We just switched places. That's it. Very straightforward. Okay, but it's important for us to be able to do that. That'll be very useful to us for some things that we do next time. Okay, so first row operation, just switch them. Switch the places. Super exciting. It's really storming out there, guys. You guys are all watching this outside as well, right? Get that umbrella up. Okay, second is what we call scalar row multiplication. All right, very similar to scalar multiplication just of a matrix, except instead of now every value in the entire matrix, it's just every value in the row gets multiplied by some scalar. All right. And if we want to divide, so maybe I don't want to multiply everything by something, maybe I want to divide by something. Okay, that's great. Well, just multiply by a fraction. Okay, division doesn't really exist, you guys. It's a hoax. Okay, division is just multiplying by a fraction. All right, in the same sense, subtraction does not exist. All right, all it is adding a negative number. Okay, so you've been lied to. The notation that we'll use is we'll just put whatever we want to multiply it by, we'll just put that in front of whatever the row is. So what this tells me to do is multiply row 2, because that's what it says here, row 2, by 4. That's what this tells me to do. Okay, so let's do another example. This is the same matrix we started with before. And we'll have a little arrow here that just points us to the next matrix. So what I mean is this. Let's take row, I don't know. Let's take row 1 and multiply it by -3. Okay, so this only has to do with row 1. So row 2 does not change at all. Row 3 does not change at all. The only thing that's going to change is row 1. So -2 times -3 is +6. -4 times -3, +12. So we did scalar row multiplication. Again, very straightforward. One thing though, if, like, let's say, as I look at these two, one thing that'll be important to us is noting when an entire row is divisible by something. So for example, -2 and -4 are both divisible by 2. So maybe if I wanted to divide them both by 2. So another option for what I could do here, let me, let me do this again. So let's say I want to divide by 2. So remember, dividing by 2, same thing as multiplying by 1/2. Actually, I'll multiply by a negative as well, just to get rid of the negatives. Again, no particular reason right now, but just to show that we can do it. In the future, we'll do it. So -2 times -1/2, that's just like -2 divided by -2, so that's 1. -4 times -1/2, that's just -4 divided by -2, so +2. Row 2 doesn't change. Row 3 doesn't change. Okay, so just showing how that could work with a, if I want to divide something, which we will want to do definitely in the future. So if we want to divide, just multiply by a fraction. Ugh. Okay, add multiples of one row to another row. This is the tricky one. This is the one that messes people up. So hello, Janasia. My notation will look something like this. And here's what always screws people up. Okay, whatever this is, this row will not change. Okay, whichever one of these is in the first spot. So row 1 is the first row out of these two. The row that's in this spot will not change. Okay, we are merely using this row to do something in order to change this row. Okay, so this row will, y'all should write that down. Thanks for showing up and bossing everyone around. This row will change. Okay, so whatever the second row is that you see in this notation, or this in this spot of the notation, this is the thing that will change. Now it freaks people out because they see, well it says 5 times row 1, so I must be changing row 1 and multiplying by 5. If it were just 5 times row 1, yeah, row 1 would be changing. But when it's in this format, it means we're doing something else. Okay, we are using row 1 in order to change row 2. Right, so let's see this in action a couple different ways. All right, first example. Let's do 2 times row 1 plus row 3. And I just am coming up with this rule just randomly, just to practice it. I don't have a reason for choosing 2 or row 1 or row 3. Right, again, in the future, we'll have reasons for which rows we pick and what we do, but for right now, it's just for the sake of practice. Okay, so the first thing, note, whatever's in this first spot does not change. So actually, I'm just going to copy row 1 down exactly how it is, -2, -4. Now, it is not because row 1 will never change. It's just because whatever the first row is that's listed here in this notation, that is the thing that does not change. Okay, but whatever the second thing is, this thing will change. So row 3 will change. When I get done doing this operation, 5-1 should not be there anymore. Okay, it should be something else. But for the time being, this says nothing about row 2, so row 2 is just going to stay exactly how it originally was as well. I don't need to do anything to that. And for row 3, so now here's where we have to do the actual math. So we're going to take all the values from row 1, multiply them by 2, and then add them to their corresponding value in row 3. Okay, so 2. So I'm going to first take whatever's in row 1, multiply by 2. Okay, negative 2 times 2 is negative 4. And then negative 4 plus 5 is 1. Right, same thing out. So now I move over to the next one. Negative 4 times 2 is negative 8 plus whatever's in row 3. So negative 8 plus 1, negative 7. Right, so this is how we got 1. And then 2 times negative 4 plus 1. This is how we got negative 7. Okay, it's a little weirder. We got to keep track of more stuff. All right, let's see it again. So let's say negative 4 times row 2 plus row 1. Okay, so whatever's in this first spot will stay the same. So 3, negative 1, positive sticks. What the hell? Let's say positive 6. Okay. Now, to get the rest of this, row 1 is going to change. So we are multiplying the stuff from row 2 by negative 4 and then adding it to the stuff in row 1. So 3 times negative 4 is negative 12. Negative 12 plus 2, negative 10. Right, so that's negative 4 times this thing plus 2 gives me negative 10. Now, I wouldn't recommend writing that on the matrix, but just showing you. So negative 1 times negative 4 is positive 4. Positive 4 plus positive 4, positive 8. 6 times negative 24 is negative 24. Negative 24 plus negative 5, negative 29. Okay, so that's how that row operation works. All right, a little trickier. Just have to be familiar about when I see this notation of 2 times row 1 plus row 3. What does it actually mean? Which row is changing? Which row is staying the same? What am I multiplying and adding together? Okay, so let's just practice using all these together. This is also a type of question you'll see on the PFA for matrices. All right, you'll see questions that are exactly like this. All right, where they say, perform the indicated row operations on the matrix in the indicated order. So it'll start off by telling you a matrix, and then it'll say, do these things to it, and then tell me what we get after we do those things. So this is where we start. So our first step is swap row 1 and row 3. All right, I can do that, I think. So I'll first switch row 1 and row 3. So negative 2, 4. Row 2 stays exactly how it was, no change. 3, 5. Great. Ta-da. We're geniuses. All right, let me cross that off the list. second thing it wants me to do, so now I'm going to use my new matrix here to do this second thing, which is scalar row multiplication. So 4 times row 3. All right, so this is 4 times row 3. That means row 1 stays the same. Row 2 stays the same. Row 3 just gets multiplied by 4. 3 times 4 is 12. 5 times 4 is 20. Cruising. All right, and then the third row operation, 2 times row 2 plus row 1. All right, so this is the one that gets a little tricky. Two times row 2 plus row 1. So row 1 is the thing that's going to change. I know that because I'm familiar with the notation. I know that row 2, even though it's telling me to use row 2 will stay the same. So I'll leave that the same. And this says nothing about row 3 whatsoever. So row 3 should also stay the same as 12 and 20. Okay, so now let's do 2 times row 2 and add it to row 1. So 1 times 2 is 2. 2 plus negative 2 is 0. 2 times 0 is 0. 0 plus 4 is 4. So this is what I end up at. After I do those row operations. Now again, I just randomly picked these 3 row operations just so we can practice using them. I had no reason to choose those specifically. In the future, we'll have reasons for what we want to do. And the last thing is, for the PFA, the answer choices won't just be this matrix. Here's what the question will actually ask. The question will say, hey, do these 3 row operations and then tell me what do you get in the what do you get in the A31 spot? All right, it'll say, what does A31 equal? All right, well, hopefully you remember what this notation means, right? A31 tells me the first number is the row number, and the second number is the column number. Okay, so in my final matrix, row 3, so that's right here, and column 1, that's right here. So what number is in that spot of the third row but the first column? 12. Okay, so just be aware of that. It'll ask you to do these row operations, but instead of giving you multiple choice answers of, is it this matrix or this matrix or this matrix or this matrix, it'll just pick out some random spot and say, hey, well, tell me what A31 is. Okay, it's 12. Or maybe it'll say, what's A32? Well, 32 would be 20. Or what's A11? Well, A11 is 0. Okay, so just pick out whatever it asks for. Okay, let's do another one. So I have a larger matrix here. This is a 3 by 4. It doesn't matter. Matrix operations can always be done on any matrix. You don't need a specific size matrix to do interchange rows or to scalar multiplication or to do the add multiples of one row to another. It doesn't matter. You can always do matrix operations on any matrix you want to. Okay, so step 1, swap row 1, row 3. Great. So 4, 4, 4, negative 8. What is this? Row 2 stays the same, so I don't need to do anything to it. Just copy it down again. And then 5, 2, 1, 0. Boom. Just swap row 1 and row 3. Now, there is a particular reason why I chose 1/4 times row 1, because now when I look at row 1, I notice all of these things are divisible by 4. Great. So that's why I'm choosing to do 1/4 times row 1. Okay. So in the future, that'll be something we need to recognize and then say, hey, I should do this. For right now, it's just because that was the next thing that it told me to do, but that's the reasoning behind why. So 4 divided by 4, 1, 1, 1. Negative 4 divided by 4, negative 2. Row 2 stays the same. Row 3 stays the same. Done. And then my third matrix operation -5 times row 1 plus row 3. Okay. Now, since row 1 is the thing that we're multiplying by -5 to add to row 3, row 1 will not change. Right? You have to have in your head, whenever I see an operation like this, this first row, whatever's in this spot right here, does not change. So I'm just going to copy that exactly down. 1, 1, 1, -2. Also, this has nothing to do with row 2, so I'm just going to copy down row 2 as well. -1, 3, -1, 2. The only thing that's going to change here is row 3. So let's do the operations now. -5 times 1 is -5. -5 plus 5 is 0. -5 times 1 is -5. -5 plus 2, -3. -5 times 1, -5. -5 plus 1, -4. -5 times -2 is +10. +10 plus 0, +10. Okay, so this is the final matrix I get. Again, if this were the PFA, it would ask you for something maybe like this. It will say, hey, now once you do all that stuff, what's A1 for? So remember, what does the 1 represent? The 1 represents, hey, first row, and that 4 represents fourth column. Rows always come first and then columns. So first row is here, fourth column is here, so -2. But it could ask for anything. It could ask for 2-4 or 3-4 or 1-1 or 3-2 or 2-3 or 2-2, you know, whatever.